All right, hi guys. Today we're going to do the review for Unit 8, which is Organic Chem. There are 72 questions. I did make a few mistakes though. There are a few questions that are repeats, so just ignore that. However, let's just get right into it. So number one, which products are obtained when CH4, which is methane, burns completely in an excess of oxygen? So they're giving you an organic molecule. They're saying that it's burning in oxygen, and there's also plenty of it. So what this means is that it's actually complete combustion. So we actually saw this in the lab. This is when you get that nice blue flame with the double flame, type C flame. And so this is describing combustion. And you have two products when you have complete combustion. You have carbon dioxide and you have water. So we're going to want to go with choice B. Question 2, what is the structural formula for diethyl ether? Okay, so if you go to your reference table, you will see that your functional group for an ether is this: you have an oxygen kind of plopped in between two. You can think of them as like side chains of carbons. So R, however long that chain of carbons is going to be, and then R, we just put this little prime showing you that it is some other or some different sort of chain, again, of carbons, however long that may be as well. So, and we're looking for diethyl, which means that we have an ethyl group on both sides. So we should be looking for something like this. And then again, you go ahead and fill in all your hydrogens. Again, every carbon needs 4 bonds. So we are going to end up going with choice B. We can see right here, there's our 2 carbons on that chain. There's our 2 carbons on that chain. So this, again, each side of an ether is sort of treated as if it were a hanging branch. So we call each side an ethyl group. This would be an ethyl group right here. This would be an ethyl group. But instead of saying ethyl ether, we just say diethyl ether. So that would be, again, choice B. All right. Let's move down. Number 3, which is the structural formula for an unsaturated compound? So just be careful when you get these sorts of questions and be very mindful of the language that they're using, because a lot of times they say unsaturated hydrocarbon, but here they're not saying that. They're just saying compound. So you can go with something that doesn't necessarily have only hydrogen and carbon. You can go with any of these, okay? You'll notice that none of these are actually hydrocarbons, okay? So we're looking for something unsaturated though, which means that it's going to have a double or a triple bond. So you're looking for an alkene or an alkyne, and there you go right here in choice A. We see a double bond between our 2 central carbons. So this is unsaturated. It means that we can break this bond and we can add other things into the compound if we wanted to. Number 4, which molecule contains a triple covalent bond between adjacent carbon atoms? They're asking which one is an alkyne. Okay. You would want to go to table Q for this. If you don't know them, if you haven't memorized them, go to table Q, look up the general formulas. You will see that this matches the general formula for an alkyne, okay? General formula for alkynes, I'll write it over here. So N always represents your number of carbons, okay? Here I can see that I have 2 carbons, so I'm just going to plug in 2 and then follow suit. So 2 times my number of carbons minus 2, that's 4 minus 2, and this does match up. It comes out to C2H2. You can also draw them out if you want to. So if you were to draw C2H2, so there's 2 carbons and there's 2 hydrogens. This is what you have, but this is obviously incomplete because carbons always need 4 bonds around them. So I can make this a double bond, but that also doesn't work. It helps, but it doesn't fix it. If I were to add another bond in, now each carbon has 4 bonds, and you can see that there is clearly a triple bond between our 2 carbons. All right, let's get rid of all this stuff. Number 5, they want us to draw the structural formula for butanoic acid. Butanoic acids, or butanoic acid, is an organic acid. Organic acids, their functional group is called a carboxyl group, can only ever be at the very end of a molecule. So that's, for example, why this name does not have a number. So I'm going to go first, I'm going to start with the prefix but. But is our organic prefix for 4. So I'm going to go ahead, 4 carbons. I'm going to put single bonds. And then I see I have oic acid. This is the ending for the organic acids. So if you don't remember the functional group for organic acids, or for any of them, you can go to table R and they show you all functional groups. And again, carboxyl group can only be at the very end. And so it's always a carbon that is double bonded to an oxygen, and it also has this OH group. This is not an alcohol though. If it was an alcohol, this double bonded O would not be there. Okay, now I have to go and I have to fill in the rest of everything else. I cannot just leave it like this. I also need to add in all my hydrogens. Remember that every carbon wants 4 bonds. So this carbon right here needs 2 more. Wait, my marker disappeared. Hold on. So this one needs 2. This one also needs 2. This one is at the end. Ones at the ends usually need 3. And let's take a look at this one. This carbon has 1, 2, 3, 4 bonds. It doesn't need anything else. It's already happy the way it is. So this is butanoic acid right here. That would be our structure. All right, let's go back up. Number 6. Which structural formula represents 2-propanol? So prop, want to make sure I've got 3 carbons, okay? I see all of them are 3 carbons, so I'm going to have to go based off of something else. I see OL. This means that I have an alcohol. That means I should be looking for a hydroxyl group. Hydroxyl group is an OH group, and we only have 1 hydroxyl group. So this one, out. This one, out. It's between A and B, and the one that we're going to want to go with is the one where they are telling us that the hydroxyl group is on the second carbon, which should be choice B. Over here, A, this would be an isomer of 2-propanol. That's 1-propanol, but they are not the same compound. That is, this hydroxyl group right here is on the first carbon. This one is right here on the second carbon. So this one, choice B, is 2-propanol. All right, number 7. Which hydrocarbon has more than 1 possible structural formula? What they're basically asking is which one of these has isomers. And in order for something to be able to have an isomer, it has to have at least 4 carbons. So our only option is this one. This is butane. The others don't have enough carbons in order to rearrange their structures. Number 8. Which equation represents an esterification reaction? So again, in an esterification reaction, you end up with an ester, okay? And you also end up with some water. So that is what we should be looking for. So water should be one of our products. So this one is pretty easy because you can just go based off of the water thing, at least for this example. The only one that has water as a product is C, okay? But let's go through the whole esterification reaction. Again, in esterification, you start off with, this is an organic acid right here. This is an alcohol. Combine an organic acid and an alcohol, and you end up with the main point of the reaction. You end up with an ester, and water is one of your byproducts. So choice C. Okay. Number 9. Which equation represents a substitution reaction? Okay, so substitution. Something to remember about this one. You're always going to start off with an alkane. Okay, alkanes have the general formula CH2N+2. Okay, so the first thing is I see choice D, and I'm going to eliminate this because that's a combustion reaction. You have some organic molecule exposed to oxygen, and you end up, oh, wait, nope, this is not. Never mind, scratch that. Or is this a mistake? This is a mistake. This is a typo here. See how we have carbon on this side of the reaction and no carbon over here? This should be CO2. Come on, reagents, that's a typo. That should say CO2. This is a combustion reaction, okay? So that's definitely not it. Now what we have to do is we have to look for the thing that starts off with an alkane. If you look at choice B and choice C, you'll see an example of choice B. Hydrogens, you have 8, carbons, you have 4. That means you have double the amount of hydrogens as you do carbon. That follows this formula. This is for alkenes. So does C. C also is an alkene. So these would not go through substitution. Alkenes would go through addition. You would break those double bonds and then you'd add something else into it because you're opening up those carbon bonds for other things. All right, so we would want to go with choice A. We are taking, this is propane, and we are replacing one of our hydrogens with one of the chlorines. And don't forget, we always have some sort of byproduct of a substitution reaction, and it will be an acid. Not an organic acid, but it will be an acid. Number 10, which substance is made up of monomers joined together in long chains? So what they're asking us is, which of these things is a polymer? And this is my class, proteins. Proteins are polymers. So they're made up of many tiny little individual pieces. And the monomers to proteins, what are they made up of? They are made up of amino acids. You should have learned this in living environment. So a bit of review. Number 11. Which formula represents a saturated organic compound? When they say saturated, we mean alkene, or something that only has single bonds between your carbons. So again, you're actually just looking for something that matches this formula. Okay, and that again is going to be this. This is propane. That is saturated. All the carbons have 4 bonds around them, no double bonds, all single bonds. All single bonds. Let me just get rid of all this stuff. Oops. Sorry for the clicking. I don't know if y'all hear it on your end, but okay. Moving on, page 2. Okay, number 12. Which hydrocarbon will undergo a substitution reaction with chlorine? Again, we just went over this. Substitution reaction, you have to start off with an alkane. So all you got to do here is just look for the alkane. You can tell by the ending, it is going to be choice D. Butene, alkene. Propene, alkene. Ethine, alkyne. Again, you got to start off with an alkane. So our only option is to start off with methane. Number 13, which statement explains why the element carbon formed so many compounds? This is because carbon has 4 valence electrons, and carbon can form endless chains, networks, and rings with other carbon atoms. It can form many, many covalent bonds in many different ways. So we want to go with choice A. Carbon readily forms covalent bonds with other carbon atoms. Number 14, esterification. We kind of did this question already. Esterification is the reaction of an acid with an alcohol, an organic acid with an alcohol. And again, this is what lab 22 is based on. Okay. Number 15. We're given this condensed structural formula, HCHO. Okay. Now, just a kind of like a piece of advice or a tip is if your condensed structural formula ends in CHO, it's probably going to be an aldehyde. But anyways, let's go ahead and draw this so we can actually see what it looks like. So we've got H, it's attached to a carbon, and that carbon is attached to another hydrogen and an oxygen. And I know something is wrong with this. Carbon here only has 3 bonds. So what do I got to do? I can't make a double bond on my hydrogens because hydrogens only have 1 valence electron. They can only form a single bond. Oxygens, though, have 2 valence electrons that are available for bonding. So they always have 2 bonds, typically. So this is what our compound would look like. And right here, this is our aldehyde functional group. This specifically is methanal, or commonly known as formaldehyde. This is what we can use to store organisms. Something that you'd see, for example, in like a museum or something like that. Or if you're doing a dissection and it takes a few days, you would store the animals in solution of formaldehyde. All right. Next, number 16. Which of the following hydrocarbons has the lowest normal boiling point? Actually, this is kind of like my bad because I didn't really talk about this too much in class. So when you have hydrocarbons and you're trying to think about their boiling points, the smaller they are, the lower their boiling points are going to be. It's going to be easier to boil something that is lighter, really like by weight. It's lighter by weight, smaller. The real reason that smaller, I'm going to write this down, smaller hydrocarbons have low boiling points because of weaker intermolecular forces, lots of abbreviations, guys. So smaller hydrocarbons have low boiling points because they have weaker intermolecular forces. So what you want to do here is you want to look for the thing that has the least amount of carbons. That'll probably be the thing that has the lowest amount of weight. So bute, that's 4 carbons. Prop, that's 3 carbons. Pent, it's 5 carbons. Ethane, 2. So we're going to want to go with ethane. That's going to be the smallest molecule. It's probably going to have the lowest boiling point. You can also kind of think of it like this, right? If you have a chicken nugget, just a chicken nugget versus a whole chicken, which one will cook easier? The smaller thing will cook easier, okay? So same kind of concept here. Chicken, the whole chicken will take a lot longer to cook. All right. Okie dokes. 17. A compound with the structural formula below should be classified as what? So you need to be able to recognize your functional groups. Right here, I see I have a hydroxyl group or an alcohol group. This makes it an alcohol group. Again, that OH is called a hydroxyl. This word is not on the reference table, so please make sure that you know it. 18, functional groups are used to classify organic compounds. I hope you all know that one. Okay. Moving on to 19. Okay. So they give us this compound, they give us the condensed structural formula, and they're asking, it is an example of what? Okay. Now, the way that I do this, just, from looking at this stuff so much, if you just see this in the middle, not at the end, but in the middle, right, of a compound, of the condensed structural formula at least, this is indicative of an ester. Okay. But let's draw it out anyways. So again, to draw these things out, and that can always help you figure out what you're looking at. Our first little group that we're going to draw is right here, the CH3. So we have a carbon with 3 hydrogens. And that is attached to a carbon with 2 hydrogens. So carbon, 2 hydrogens. And what is that attached to? Well, that is attached to a carbon. Another carbon that is attached to 2 oxygens. So one here, one here. Then that is attached to our final little group here, that little CH3 at the end. So CH3. Now there is something wrong with this, okay? Because this carbon right here only has 3 bonds. So that means that it has to be double bonded to something. So it's going to be double bonded to this one. Can't be double bonded to this oxygen, because then that would give oxygen 3 bonds. Oxygen doesn't like 3 bonds, it likes 2. So right here, see this is indicating you have an ester, okay? All right, so trace B. Number 20, which structural formula represents an organic acid? Again, please make sure that you can identify your functional groups. Right here on choice C, we see that we have a carboxyl group. That is giving us our organic acid, and to be specific, that is propanoic acid. It's got 3 carbons with an organic acid or carboxyl group at the end. All righty. Number 21, which structural formula represents ethene? So I see that my prefix is F. That means that we've got 2 carbons. So automatically I can get rid of C and I can get rid of D because those have 3. Now I also see that it has an ending ENE. This means I have an alkene. So I should be looking for a double bond right here. I see 2 carbons double bonded to each other. So this is ethene. B would be ethane because the bonds between the carbons are single bonds. 22, which formula represents a hydrocarbon with a double covalent bond? Again, you'd want to go to table Q if you don't have them memorized. If they're saying double covalent bond, it's a double bond. So that means that you have an alkene. General formula for an alkene is CnH2n. However many number of carbons you have, the hydrogens will always be double that amount. So I can see right here, 4 carbons, and I have double the amount of hydrogens. I have 8 hydrogens. So that is my alkene. Okay. Also, C and D would have been easily eliminated because the question says hydrocarbon, and I can see in both C and D, I see chlorine. So C and D are not hydrocarbons at all, okay? And A, by the way, would be an alkane, that is butane. All right, 23. I feel like I put this question so many times. A reaction between an acid and an alcohol produces an ester, and what else? You also get, you get a byproduct, and your byproduct is going to be water. Not necessarily the aim or the goal of the reaction, but it's something that we end up with as one of our products. All right, moving on to the 3rd page. 24. Base your answer, yada, 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 yada. They give you all this information, and at the end of the day, they're asking, identify the element in these 4 compounds that makes them organic compounds. So they give us methyl isocyanate, propanone, propanal, ethanamide, all these things. But really, you don't even need to see that, although please make sure you read thoroughly every little passage that they give you on the region. But at the end of the day, they are just asking you what element makes all these organic compounds organic. The compound, the element that makes anything organic is going to be carbon. So our answer is carbon. That is all you have to write. Okay, 25. In which kind of reaction is soap one of the products? That is going to be saponification. Okay, right here, you can see the beginning. If you rearrange it, it looks like soap. You can spell soap, so that's how you can memorize it. All right. Number 26, which equation represents an addition reaction? So addition reactions means you're adding something to a compound, and the only things that you can add to are unsaturated things. So that means something with a double or a triple bond. So you can only do this with alkenes and alkynes, okay? Choice 1 is out of here because that's a combustion reaction. So it's really B, C, and D. And again, we have to look for something that is either starting with an alkene or an alkyne. So I'm just going to look at the formulas of my little organic compounds here. C2H6, that follows the alkene formula. So that's not it. That's ethane. C4H10, that's butane. That doesn't work. This is propene. C3H6, that has a double bond. I'm going to draw this out for us. Okay, so we're starting off with 3 carbons. And just pretend that I'm filling in the hydrogens, okay? So we're starting off with something unsaturated. This has the ability, these carbons have the ability to take on some other things, okay? But first, what we would have to do is we would have to erase too much. We would have to get rid of that double bond, okay? So now we would have only a single bond between them. But you can see that these 2 carbons are unhappy now. They need 4 bonds in total. So you would add something here and you can add something here. And in this case, the thing that you're adding would not be hydrogens, but they would just be chlorines. This would specifically be halogen addition, but you don't really need to be specific. Like for example, like in a short response question, if it's halogen addition versus hydrogen addition, you can just say addition. Like you don't have to be so specific. All right, so our answer for 26, choice D. Number 27. Which is the structure for 1,2-dibromoethane? So I see the word F. That's like our tree trunk, our parent chain. Ow, I just kicked the table. My poor toe. All right, so F, that is our prefix for 2, and we're talking about 2 carbons. So I can get rid of A, I can get rid of B. This has only 1 carbon. This has 3. So it's between C and it's between D. Okay, now they give us the locations for our bromo groups. I can see here for choice C, they're both on the same carbon. So this is 1, 1, di, yada, yada. This one here has a bromine on the first carbon and 1 on the second carbon. So this is the one that we want to go with, choice D. Okay, next, what is a product of both fermentation reactions and saponification reactions? So again, there's always going to be some, like, not always, but for some reactions there are byproducts, not necessarily something that you're looking for, but you end up getting anyway. So one of the byproducts of saponification is alcohol, right? You're trying to make soap, but you end up getting a little alcohol. In saponification, you get glycerol. And fermentation, you know, this is the goal of it. You are trying to get alcohol, and you would get ethanol specifically. Okay, so your one of your products for both of these reactions would be alcohol. All right, let's get rid of all this stuff. Okay, 29. Which polymers occur naturally? Okay, so it is going to be choice A. Okay, starch and cellulose are both found and created naturally. If you look at the other choices, starch is good, but nylon is synthetic. Nylon is synthetic. Plastic is also synthetic, so none of those choices work. 30. Which formula represents ethanoic acid? Here's another tip, okay? If you see a condensed structural formula and you see COOH right at the end of the formula, that's going to be your organic acid, okay? This is ethanoic acid. Let's take a look at the others anyways, though. A, there's your hydroxyl group. Remember I said this one before, if you see COOC in the middle, That is going to be an ester. These are like little tricks to help you. You see an O in the center and you see 2 carbon chains on both sides. This is an ether. All right, 31. Given the structural formula for ethine, what is the total number of electrons shared between the carbon atoms? So I see a triple bond. Remember, every dashed line equals 2 electrons being shared. Because there are 3, that is 2 times 3, and 6 electrons are being shared between them. Number 32. What is the chemical name for the compound CH3, CH2, CH2, CH3? So what I'm going to do, I know just by looking at it that it's butane. Okay, we can get rid of C and we can get rid of D because I can see that there's 1, 2, 3, 4 carbons. So that's but. Okay, now I just need to know, is it an alkane or is it an alkene? So is it going to be butane or is it going to be butene? What you can do is you can draw it out, or you can count everything up and write the molecular formula out. So I know I have 4 carbons, and if I add everything else, I've got 3 hydrogens here, 2 here, that's 5, plus another 2, that's 7, plus another 3, that is 10. This follows the general formula for alkanes. So we're going to want to go with butane. This is butane. All right, let's get rid of, where is my eraser? There we go. All righty. Which kind of bond is most common in organic compounds? Hope we know this one. Mostly everything is carbon and hydrogen bonds, all non-metals. So these are going to be covalent. All right, number 34. Okay, so they give us all this information, and then they want us to explain in terms of molecular formulas and structural formulas why 2,2-dimethylbutane is an isomer of hexene. We don't even need to know the formulas for these. They are telling us that they are isomers. The only reason that 2 things would be isomers is because they have the same molecular formula, but different structure. Also notice how I'm using the words that they've given me. They're saying explain in terms of molecular formulas and structural formulas. So make sure that those words are in your response. Okay. So again, same molecular formula. They're made up of the same stuff, but they are not the same compound. They are isomers because they have different structures. And again, different structures gives rise to different properties, different physical and different chemical properties. Okie dokie. 35. So again, another one where they give you this text. So write the name of the class of organic compounds to which both geraniol and I don't know how to say that one. Oh gosh. That thing. Okay, my bad. English. Okay. So I see here and here I have OL endings on both of my words. So these are going to be alcohols. Okay. This is not necessarily, these names are not necessarily following the procedure that we use, but certain compounds will have what we call common names. Again, remember when we did H2O, its real name is dihydrogen monoxide, but no one walks around saying that. We just call it water. That's the common name for it. So same thing here, but both of those are considered alcohols. And also, another thing to kind of clue you in is that on them, you can also see they have hydroxyl groups. That makes it an alcohol. Okay. Sorry about the dog barking. Okay. Number 36, the isomers butane and methylpropane have, it's your options. So again, they're telling us just right off the bat that they are isomers. Isomers are going to have the same molecular formula. They've got to be made up of the same stuff. So it's not A, it's not C. They have the same molecular formula, but they have different properties because they have different structures. So we're going to want to go with B. 37, which is an isomer of 2-chloropropane. So it's definitely not going to be B. And it's not going to be C because they're telling us they have 4 carbons. Again, isomers have to have the same composition. So if 2-chloropropane has 3 carbons, its isomers also have to have 3 carbons. So it's really between A and it's between D. But if you look at D, it's just propane. Okay, there is no chlorine in this. There's no chloro group, so it's definitely not this. This would be what we want to go with. So this is an isomer because you're just changing the location of the chloro group. 38. Which substance is an important source of organic chemical products and fuels? We spoke about this in lesson 8.1. We spoke about petroleum. Okay, so we extract this and we can break it down into many different products that we use on a daily basis. All right. 39. Which structural formula represents a compound that is an isomer of this thing that they give us right here? So what I'm going to do is I'm actually going to go ahead and name it. Okay. This is 1,1-dibromo. This should be one word, but I don't have space. Butane. Okay. So I've got 4 carbons. I've got 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. I think I counted that right. 1, 2, 3, 4, 5, 6, 7, 8. Yes. And 2 bromines. Okay. And both of the bromines are attached to the first carbon. So A looks like a good contender, okay, because I have a bromo group here on the first carbon and here on the third carbon, and I have a 4-carbon chain. So the structure is different, but the molecular formula is the same. So this is the one that we're going to go with, but let's look at the other ones and see why they don't work. Let me just get rid of this. Okay, so choice B, hold on, sorry y'all. Let me get rid of everything and let me kind of like zoom a little bit. Can I? No, I can't. Stuck on this. Okay, if you look at choice B, it is exactly the same thing. We have just rotated the molecule. It's exactly the same. Choice C is not good because there's 3 bromines. Our thing that we were trying to compare it to only has 2, so the molecular formula does not match. And D also is no good because this has a 5-carbon chain and ours has 4-carbon chain. So again, it's got to be made up of the same stuff. So this one is going to be choice A. Number 49, when C3H8, which is propane, burns in an excess of oxygen, the products formed are, again, this is a combustion reaction. Your products are always the same: carbon dioxide and water. Number 41, which substances are products of a fermentation reaction? So through fermentation, we get alcohol, specifically ethanol, and we also get CO2. Remember that I used the example of baking bread, okay? We have some sugar, we add yeast, and the yeast has an enzyme called zymase, which will break down the sugar. And any organism has to eat, and when it eats something, it breaks it down and it produces waste. So the yeast will produce alcohol and it will also produce some carbon dioxide. This is why when you add yeast to bread, it will rise because you are creating a lot of carbon dioxide, which is a gas. So it causes bubbles. So we're going to want to go with choice C. All right. 42. Which compound is an ester? Again, just look out for what I told you before, that little trick right here. If you see COOC in the middle of your structural formula, your condensed structural formula, that is going to be your ester. But I will just draw this out anyway so that we can see what it looks like. Okay, that's connected to a carbon. And that carbon is connected to 2 oxygens and then another CH3. All right. This is actually the one that I gave you guys on your quiz. That is methyl ethanoate. Alrighty. Let me get rid of this stuff. Number 43. We kind of just spoke about this one. So the fermentation of, this is sugar or glucose, will produce carbon dioxide, and you will also get alcohol, okay, specifically ethanol. And you guys know how to name stuff, so you can figure out what this looks like. F is 2 carbons. There's a hydroxyl group. There's only one possible location. It can only ever be on the first carbon. And then we will go ahead and fill everything else in with hydrogens. So this is C2 We've got 2 carbons. We've got 1, 2, 3, 4, 5 hydrogens. And then we have an OH group. We could just write that right at the end. And that matches up with choice D. A and C, terrible. Those are not even organic compounds, okay? This is bad. No good. Okay. Oh, by the way, though, they are good to look at because you do see the OH, but when it's written like this, choice A and C are ionic compounds. And when that OH is written like that, that's not hydroxyl group. That is a hydroxide ion. Looks like this. One of our polyatomics. Not the same thing. Looks similar, but not the same. All right. Okay, this is one of the questions that I asked, I think, literally 3 times. I don't know what's wrong with my brain sometimes. Okay, so again, make sure you know your functional groups. If you don't know them, use table R. They are right there for you. So we're given this structural formula, and we want to know how you would classify this organic compound. And right here, I can see that I have an amido group. So this would make it an amide. Okay. Number 45, this is something I mentioned in class. Okay, wasn't in the notes, but I did mention it out loud. All right, so this structural formula represents a molecule of what? I can see right here, I have an organic acid group or a carboxyl group. And right here, I have an amino group. What do you get when you have a molecule with an amino group and an organic acid? Well, you get an amino acid. Amino acid has to have both functional groups. And these are monomers of proteins. You put a bunch of amino acids together, link them through polymerization, and you make a protein. Number 46, I also asked this one a bunch of times. The reaction of an alcohol with an organic acid produces a compound classified as an ester. This is esterification. All right, we are moving along very nicely. Next page. Oh, nope. Had my hopes up. Okay, which is represented by the structural formula above. And I can see right here, a very small molecule, but this is my what is that? Okay, never mind. Sorry. This is an aldehyde group. My carbon double bonded to my oxygen and single bonded to my hydrogen, and is at the end of the molecule. Again, this one is methanal or formaldehyde. Okay. Next, number 48. They give us all this information, they give us drawings, and then they ask us state the number of electrons shared between the carbon atoms in a molecule of vinyl chloride. So right here, they label it for us. This is vinyl chloride, and they're asking us between these 2 carbons, how many electrons are they sharing? Not pairs, but say the number of electrons. They've got a double bond. Each single bond represents 2 electrons being shared. So it's 2 times 2. They are sharing 4 electrons. By the way, this is a nice example of a polymerization reaction. Oops, that's not the eraser. Okay, this is a good example of a polymerization reaction, specifically addition. This is addition polymerization is what we use to make synthetic polymers. PVC, we should know, it is a type of plastic. You can make lots of things out of it. Usually you'll see it being made for PVC pipes, okay? Again, you always start off with something that is unsaturated. So here we're starting off with a double bond, starting off with vinyl chloride, okay? And then what we're gonna do is we have a bunch of these things, a bunch of these molecules. We break their double bonds, and then it allows them to basically form a big, long, like chain or big link with each other. So then you get your polymer. In this case, you get polyvinyl chloride, PVC. Okey-doke. Number 49. All right, so they want us to draw a structural formula for the unidentified reactant X in the equation. So this is an esterification reaction, okay? I know it's an esterification reaction because I can see here that I'm starting off with butanoic acid. That's an organic acid. I don't know what this reactant is, but I have a pretty good idea at this point. Okay, and I can see here that my product, this is an ester. So I know that this is esterification. Okay, in esterification, my other reactant is always going to be an alcohol. Okay. So what I'm going to do is I'm going to basically just redraw all of this stuff in a moment. But our alcohol, okay, again, in an esterification reaction, what happens? You have your alcohol, and that entire hydroxyl group basically just gets like kicked off. Okay. So you see this double bond here. Okay. I'm going to kind of like cut this off a little bit right here, this whole section. Okay. This came from my organic acid right here. Okay. What comes off of the organic acid is the hydrogen. So the hydrogen goes bye-bye. Okay. And then the other reactant over here, it's my alcohol. It's going to attach itself to this oxygen. So this is where my alcohol came from. Okay, so I'm going to draw that out. But obviously, if I write it like this, it's not an alcohol. Those are H's, by the way. This had to have a hydroxyl group. That was right here. Okay. Remember, this whole hydroxyl group comes off. And this carbon is going to attach to this oxygen and give us this entire molecule. Okay. And again, remember that hydrogen that came off of our organic acid and the entire hydroxyl group that came off of our alcohol, they're off now, and they will come together and they will form water as one of our byproducts. Okay. You know what? I think I actually just want to redraw this whole thing just in case, because I know that this one can be a little confusing. So again, here is the organic acid that they're giving us. And you know what? Actually, what I'm going to do, let me redraw that because that looks very sloppy. Okay. I'm going to put a different color on this hydrogen. Oh, bear with me. Okay. And so before I had drawn our alcohol, and it was ethanol. That's the one that we started with. That would be my answer to this question, by the way, right here. This is your answer to the question, okay? But let me just show you again what happens. And let me redraw that actually in a different color. So again, we take an organic acid and an alcohol and we combine them together, okay? And what happens is this OH group comes off, gets detached, okay? So I'm just gonna draw that HO group. We got it right over there. And this hydrogen on our organic acid also comes off. So I'm gonna draw that over here. Again, that is how we end up with water as one of our byproducts. Now we can see here that my oxygen, this oxygen is not happy. Oxygen likes to have 2 bonds. This carbon is not happy. It only has 3 bonds, but likes 4. So what happens? These 2 things attach, and this is this. That is how we end up with that ester. That is ethyl butanoate. Okay. But again, that is how I figured out what my alcohol was. It was originally this part, and it had a hydroxyl group on the end. Okay. So my final answer, again, I'm just going to rewrite it. Sorry, this is taking so long, this question. But I want to make sure you guys really get this, especially because we're going to have a lab on this one. This would be your answer for this question. Okay. So that is ethanol. All right. One second, sorry. Oh, sorry, y'all. I gotta get some water. Because I am talking a lot. All right. We're almost done. Again, I think there's like 72 questions. Okay, so number 50. We are given the structural formula of pentane, and they're asking us to draw a structural formula for an isomer, for one of its isomers. Okay, pentane has two, so I'm going to draw both. Okay, because the one that you came up with might be a little bit different. Okay, so again, pentane. So let's make sure our drawings are going to have. Oops, sorry. Let's go back to the orange. So pentane, we're going to want to have 5 carbons and 12 hydrogens. Okay, so I'm going to rearrange this thing again. An isomer has to have the same amount of stuff, but different structure. Okay, so one thing that we can do, and again, remember, you have to have new attachments. Okay, so I'm going to take off this carbon and I'm going to attach it somewhere else. Okay, and again, remember, this is my parent, this is my chain, this is my main chain. I cannot do this. I cannot do that. It is still attached to the same carbon, and this would still be one chain. Okay, so that does not work. So I have to attach it somewhere else. The only other place I can attach it is right here onto the second carbon. Okay, so now what I would do is I would just go ahead and I would fill in all of my other hydrogens. And guys, a good way to know that you actually have drawn an isomer, make sure the stuff is the same. I've got 1, 2, 3, 4, 5 carbons, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens. That works. You want to make sure that the structure is different. A good way to tell is to try and name it. This is no longer pentane because my longest carbon chain is no longer 5, it's 4. And I have a methyl group on my second carbon. So this is really now 2-methyl butane. Name is different. Okay, name should be different for your isomers. So this is one possible isomer. Your other possibility is to take off 2 carbons and put them right onto the central carbon. And then again, you would go ahead and fill everything in, all your hydrogens. You're going to have 12 hydrogens, 5 carbons, and this also is not going to have the same name. It's not going to be pentane. It's not going to be 2-methyl butane. This is going to be 2,2-dimethyl propane. Now our longest carbon chain is only 3 carbons long. Okay, so either of those work. Just make sure that when you draw it, you draw in all the hydrogens, not like what I did. Okay, so make sure you draw all your hydrogens. Alrighty, next. 51. Which organic reaction involves the bonding of monomers by a dehydration process? Okay, so this one is going to be condensation polymerization. Okay, again, if you see the word monomers, it's indicating you're making polymers, so that's polymerization. It's not going to be addition polymerization, because this, what you do is you don't dehydrate it by taking out water, okay, which is why we call it condensation polymerization, because one of your products is water. When you have condensation, one of your products is water. It's not addition because you have to start off with an alkene, okay, and this just has no involvement with water at all, okay? So 51 should be choice D, condensation polymerization. And also this is the type of polymerization that creates natural polymers like starch or cellulose or proteins, things like that. Here, I already did this question before, it's amide. It may look a little different, might have some more carbons, but here is your amido group. Number 53, which formula represents a ketone? Okay, so for this one, let me just get rid of that. Let me scroll. I'm going to zoom in a little bit. Let's see. Yeah, there we go. All right. So this one, I'm going to draw this one out so that we can really visualize this. Okay. So we've got, I would just always draw these out just to be sure. So I've got CH3, that's what I just drew out, attached to a carbon. Okay. Attached to an oxygen, I'm gonna put the oxygen there. attached to a carbon with 3 hydrogens. Okay, now, the way that I know that this is not proper right now is because this carbon has only 3 bonds. It needs 4. That has to be a double bond. And right here is my carbonyl group in the middle of a compound. Remember, when you have your carbonyl group in the middle of a compound, it's a ketone. If it's at the end, it's an aldehyde. So we're going to want to go with choice C. Next one, which one represents an organic acid? So again, easiest way to kind of pick out an organic acid is if you see the COOH at the end, it's an organic acid, okay? This one I will draw out though so that we can see it. This is what it would look like. This is methanoic acid, only 1 carbon. Alrighty. Number 55. Which is the structural formula for propanone? Also common name acetone. Okay, so prop means I'm gonna see 3 carbons. So all of them have 3 carbons. Okay, and one means it's a ketone. So I should see this, some carbon chains on both sides with a carbon and a double bond in the middle. The double bond to the O should be somewhere in the middle of the compound. It's definitely not A. That's an OH group, that's an alcohol. So that's no good. Let's see. C, also out. There we have 3 alcohol groups, definitely not. Okay, so it's really between B and it's between D. And the difference is the placement of this part. Okay, again, for a ketone, your carbonyl group, which is that carbon double bonded to your oxygen, has to be in the middle. Okay, that would be choice D. If you see here, choice B, what is this? Your carbonyl group is there, but it's at the end. It's got an H attached to it. That makes it an aldehyde. Again, the functional group for both aldehydes and ketones are carbonyl groups, but their placement dictates which functional group you really have. Okay, so if it's at the end, it makes it an aldehyde. If it's in the middle, it's a ketone. All right. Number 56, which process is represented by the following diagram? So right here, I see that I have this little piece, okay, and it also, right here, I see a double bond right there. In here, on the other side of my arrow, on the product side, I don't see any double bonds. It means that those double bonds were broken. And now I can see multiple. Here is that molecule that you see as a reactant. There's one. There is another, and they have been attached to each other, meaning that this is a monomer, and they're being linked or chained together through a polymerization reaction. So this is going to be choice A. Number 57, which is a product of the hydrolysis of an animal fat by a strong base. So when you take a base and a fat and you have them react, you will get soap. This is describing a saponification reaction. Also, don't forget you have another byproduct that will be glycerol, a type of alcohol. All right. 58. I've given you guys this question, actually. I think this was on your exit ticket for 8.4, if my memory serves me correctly. Butanol and butanone have different chemical and physical properties, primarily because of differences in their functional groups. Functional groups will impart distinctive properties upon the compounds in which they are in. So butanol, aldehydes, and ketones have different types of properties. Again, your functional group gives the compound a specific function. All right. 59. Which is the product of the reaction between ethene and chlorine? So let's draw this out. So I'm starting with an alkene, and I got a halogen. If you take an alkene and you have a halogen, and you put them together, you're going to end up, okay, with an addition reaction. halogen addition to be precise. Okay, so let's draw this. We've got ethene, that's 2 carbons with a double bond. And I've got chlorine. Remember, chlorine is one of our diatomics, Honkelbrith. Okay, so that's why I put the 2 there. Now, what's going to happen? You start off with an alkene, something unsaturated, you break that double bond. Now we've got carbon, 2 carbons with just 1 bond in between each other. Each of these carbons is not happy anymore. Okay, they're not happy like this. These chlorines, first, they are attached themselves. These break up, okay? And then they will come into place. I'm going to change the color. One will attach itself here. And one will attach itself here to this chlorine, to this carbon. So I'm just going to redraw this whole thing. So we're going to end up with ethane. Okay, we have ethane as our primary or parent chain, single bond now between our carbons. And we have a chloro group on carbon 1 and carbon 2. You also could have drawn the carbons down here and down here. It doesn't really matter how you draw it, okay? But it's not going to be A, not going to be B. Those don't have enough carbons. It's between C and it's between D. When you add halogens to a double bond, you're going to add both of the halogens. So it's going to be choice C. In choice D, they only added 1 chlorine. That doesn't make any sense. Where did the hydrogen come from? Okay. All right. Number 60. We actually did this one in class. Draw the structural formula of the product 1-2 dichlorobutane. So I'm going to start here with my parent chain. I'm going to draw butane, but I'm just going to draw the carbons right now. Now I see that I have 2 chloro groups, dichloro, and they are on carbons 1 and 2. So I'm going to draw them right here. Guys, you can draw them up here. You can draw one down here, one up here. It literally does not matter. Okay. And then I'm going to fill in the rest of everything else with my hydrogens. And there is 1,2 dichlorobutane. Let's get rid of all this stuff. I think next page is the last page. Is it? No. Is it? Nope. Okay. 61. Which 2 compounds are isomers of each other? So when you have isomers, let me zoom in actually. All right. Isomers should have the same molecular formula, different structures. Okay. So choice A, I see this compound has 1, 2, 3 carbons, and this one has 1, 2 carbons. Already no good. They're not made up of the same stuff. Okay. Choice B, I have 1. Actually, we learned this today. When you have parentheses and you have a subscript, it gets distributed into each atom. So I actually have 2 carbons here. So I have 1, 2, 3, 4. 4 carbons here. Here I have 1, 2, 3, 4 carbons. So the carbons are fine. Let's see how the hydrogens are. I've got 3 hydrogens here, 2 here, that's 5, plus another 3, that is 8. Here, what do I have? I have 3 plus 2, that's 5, plus 3, that is 8. But guys, what's the problem? Look at these 2 things. They are literally exactly the same thing. They are written exactly the same. That means that these are not isomers of each other. They are exactly the same compound. So it's definitely not B. Okay. Okay, let's look at choice C. I see I have, let me get rid of all this other stuff. All those dots kind of driving me crazy. Okay, so I've got 1, 2 carbons, 1, 2 carbons, that's good. Then I have 1 oxygen, that's good. I've got 3 hydrogens, that's 6 hydrogens on here. I've got 3, 2 plus 1, 6 hydrogens here. So these both have the same molecular formula. And if you look at them, this is an ether and this is an alcohol. So it's definitely choice C. Choice D also doesn't work. This thing only has 2 carbons and this one already has 6. So already off the bat, no good. So choice C. All right. I'm going to get rid of all my drawing. Okay, 62. Given the formula for an organic compound, this one is nice and easy. They're not asking you to name it. They're just saying, what is this hanging group? What is this alkyl group? Again, alkyl groups, I'm going to write this down. Alkyl groups with this YL ending are indicating that it is hanging off of an alkane, an alkene, or an alkyne. Okay, so this group, they want us to name this group. It's a hanging group with 2 carbons. Our prefix for 2 is F, so it is an ethyl group, choice A. Okay. Number 62. We also had another question similar to this before that I explained. In a given homologous series of hydrocarbons, that again, homologous series of hydrocarbons can be alkanes, alkenes, alkynes, the boiling point generally increases as the size of the molecules increases. The best explanation for this statement is that in larger organic molecules, there are greater intermolecular forces. We learned about this really in Unit 7, chemical bonding, okay? The greater the intermolecular forces, the higher the boiling point, the harder it is to boil something. And again, when you're talking about organic compounds, the bigger the molecule or the heavier the molecule is, the longer that carbon chain is, the harder it's going to be to get it to boil. So its intermolecular forces are going to be on the stronger side, and its boiling point is going to be relatively high in comparison to smaller hydrocarbons. All right. Number 64. Which organic product is formed by the reaction below? So we're starting off with an alkane, and I like to label everything. Alkane, halogen, and I like to just look at what happened. This hydrogen got replaced by a bromine. Okay. So also, I know that they're not asking this, but it is good to just think about it. This is a substitution reaction. Okay. The real question that they're asking us is, what is this thing called? What is the organic product formed? Okay. I know they're not asking about HBr, this acid, because this is not an organic product. This is not organic. It's got no carbon in it. This is organic, and products, again, are always to the right of the arrow. So we want to name this. Okay, there's 2 carbons, so it's F. I don't see F anywhere in choice A, so it's not that. I see a bromine, so I should see the word bromo. Okay, and also it's single bonds between my carbons, so it should be an A-N-E ending. So I'm going to want to go with choice B, bromoethane. This one does not need a number or a location, because if you have ethane, it's only 2 carbons. There's only one possible spot to put the bromo group. Okay, if you put it here, you read the numbers this way. If you put the bromine on the other carbon, you would just number it and read it going the other way. Anyway, number 65. What is the number of hydrogen atoms in a molecule of ethine? Okay. Sorry, guys, 1 sec. I just want to see my battery. Okay, it's me. Right? 20, yeah. All right. Let me read this. What is the number of hydrogen atoms in a molecule of ethine? So what you could do is you can use the general formula. I'm just going to write it over here. You can go to table Q. I see that it ends in YME. General formula for alkynes is CnH2n-2. Okay, I see here F, that means 2 carbons, so I can go ahead and plug in everything. C2, H2 times 2 minus 2, and this comes out to C2, H2. This means I end up with 2 hydrogens in this molecule. Another way that you could have done this is just by drawing out the molecule. Okay, so we know that we have 2 carbons. Oops, sorry. 2 carbons. Ethine indicates its triple bond between the carbons. And then I would just go ahead and fill everything else in. These carbons already have 3 bonds, so they can only take 1 more thing. So only 1 more hydrogen is needed, 2 hydrogens in total. All right. Number 66. One of the products of condensation, polymerization is, well, it kind of tells you also, there's a way you can remember it, is literally the word condensation. When you have condensation, it produces water. Okay, so water is one of our byproducts, aside from the actual polymer that we're making. 67, which is the general formula for an organic acid? All you gotta do is just go to table R, match it up. Here you go, it is choice C. Right here is your carboxyl group, which is your organic acid. Okay, 68. They give us all of this information. Okay. You can read through that, but the question is asking us identify the type of organic reaction by which ethene, also known as ethylene, is made into polyethylene. So we started with ethylene, one piece of ethylene, right? Or a few pieces of them. And then we have the word poly here. That means many ethylenes. This means that we have made a polymer of ethylene. So that means that we have polymerization. Okay. All right. Also, if you want to be, sorry, one sec. If you want to be a little bit more specific, okay, you can say that this is addition polymerization. You can see that we're starting off with an alkene. Also, polyethylene is a type of plastic, which is synthetic, and we use addition polymerization to make synthetic polymers. But if you polymerization is perfectly fine, you do not have to be more specific than that. Number 69. So now, which element must be present in an organic compound? We did this question already. It is carbon. If there is no carbon, it's for sure not organic. Number 70. Which structural formula represents a molecule with the empirical formula C3H6O? Okay, so let's take a look at all of these. So we've got 1, 2, 3 carbons. 1, 2, 3, 4, 5, 6, 7, 8 hydrogens and 1 oxygen. Not it. Doesn't match. Next one. We have 1, 2, 3 carbons. We have 1, 2, 3, 4, 5, 6 hydrogens and 1 oxygen. So this works. So it's probably going to be B. Those match. Let's just take a look at the other ones anyways. So we've got 3 carbons. We've got 1, 2, 3, 4, 5, 6, 7, 8. Again, 8. This is no good. Doesn't match. 3 carbons. 1, 2, 3, 4, 5, 6 hydrogens. But the problem is it's got 2 oxygens. This is no good. So our answer is going to be choice B. All right. Let me get rid of this. Okay, 71. What type of reaction is represented by the equation below? I can see that I am starting out with an alkene, starting off with hydrogen. And what do I end up with? I end up with an alkane. When you take an alkene and you turn it into an alkane, it means you're breaking the double bonds and you are adding something into it. And we haven't produced a halo alkane because this is not halogen addition. This is specifically hydrogen addition, but the choices are not being specific. So we can just go with addition. But again, you're always starting with something unsaturated, like an alkene and an alkyne, and you are turning it into something like an alkane, something saturated. 72. The process of opening double bonds and joining monomer molecules to form polyvinyl chloride, or PVC, is called, again, PVC is plastic, so it is synthetic. What do we use to make synthetic polymers? We use addition, polymerization. So we're going to want to go with choice B. Okay. Guys, I hope that this was helpful. Again, I don't have any physical copies this time, but you can view not only the video, but you can, I've posted the review sheet on my website. Just go to exam reviews and it will be there. I'll have 2 versions of it. I'll have one version with no answers on it. So if you have access to it, you can print it and you can try it out on your own. And I will also have a version of this PDF with all the answers on it. But anyways, guys, again, I hope that this was helpful and good luck on the exam.